Hello all. So in the last session we have seen um, other different pre-trained language models that are available other than BERT, right? So today I would like to focus on one case study which is spell checker with BERT. Okay. So as seen we can use BERT for many different applications, and one such application that we have chosen here today in this session is spell checking. Okay, so spell checking is most important task that we take up for most of the important NLP applications. So BERT is a pre-trained language model that we can use directly from Hugging Face library, and we can make some changes in the code and then implement any of the applications. And one such application that I am going to focus today is spell checker. Okay, so we have known that BERT can be used for contextual understanding, right? BERT, which actually stands for bidirectional encode representations from transformers, is a powerful transformer based NLP model that excels in understanding the contextual information when we talk about natural language text, right? So let's see how do we use this BERT for spell checking application. So we have seen BERT pre-training is done in two different steps, MLM and next sentence prediction. Okay, so first let's talk about masked language modeling. BERT actually can predict missing or masked words in a sentence. So this capability is crucial in spell checker, where BERT can predict the correct spelling of misspelled words which I have in the given input sentence. Okay, so I am using BERT along with integration of this BERT model with spell checker model. Okay, so BERT itself does not correct spelling mistakes directly. Okay, it can make or it can give you the prediction for the masked tokens, but these prediction can be used as suggestions for correcting misspelled words identified by another spell checking component. So here in our case study I have used this component which is called as spell checker. Okay, so we have this library called Pi spell checker library. So this particular library provides you a straightforward way to identify and correct misspelled words using pre-built dictionaries that are available. Okay, so basically it complements BERT. Pi spell checker and BERT works together with these two steps. First step is it basically performs basic spell checking. Pi spell checker will use dictionary based checks to identify words that does not exist in the dictionary or which are not spelled correctly. It can provide initial corrections for obvious spelling mistakes. By fine tuning, you can a lot of improvement in the model. And then it pre-processes the data before passing the data text to the BERT model for contextual correction. Pi spell checker can actually pre-process text to identify and correct straightforward spelling errors, which will reduce the complexity and improve the performance of the BERT-based correction process. Okay, so now we integrate these two models, the BERT model and the Pi spell checker module, which I'm importing from the libraries. Okay, so to implement a spell checker, we use this BERT and Pi spell checker. Okay, so these are the three steps that I use. First, I go for text pre-processing, where I identify and correct obvious spelling mistakes in the given text input, and then I go for contextual correction with respect to BERT. This text pre-processed data is then given to BERT for remaining or complex misspellings which are identified by Pi spell checker with respect to BERT, which is used for covering the spellings with respect to the context. Okay, so MLM here in the BERT has the capability to provide accurate predictions for masked tokens, and after I go for this, I'll go for evaluation and refinement. Okay, now let's start implementing BERT. First, we install necessary libraries. Make sure you install transformers. Basically, first I install spell checker, and after spell checker, I go for installing this library. Okay, so we install the necessary libraries in the first step. Okay, after doing that, I import the required libraries. Okay, so when I talk about required libraries, I import torch library, and from the transformers I implement BERT tokenizer. Here the model that I am using is BERT, hence I import BERT tokenizer. I am going for pre-trained language models, for which I also import BERT pre-trained model, which is called as BERT for masked LM. Okay, so these are the libraries that I import in step 2. And after I import the libraries, I am not creating the model. I am using the pre-trained language model, right? So for that reason, what I do here is I import BERT model. Along with that, I want to perform the basic necessary tokenization. Hence, I load pre-trained BERT model and tokenizer. Okay, so these are the components which we usually take from Hugging Face Transformers library, and we work with these libraries with respect to BERT models. And I also import the spell checker, a library for spell checking. Okay, so we will load the BERT token for tokenizing the text inputs, and then I load the BERT model configured for MLM, okay, which predicts masked words in a sentence. Okay, once I am done with loading the BERT model and performing the tokenization, where the tokenization is 100% done, I'll go for setting up my spell checker. Simply install the particular library. Now here comes the most important step, where I define a function to detect the spellings first and then correct. Detection is one function. I use one function for detecting the spellings, and then I obviously correct the spellings with respect to the spell checker. Okay, so first I perform input processing. I split the word given input text into words. Okay, I accept a text string text as input, and then I split the input text into individual words, as you can see using the text.split function. And then I initialize an empty list, as you can see here. I initialize an empty list to store the corrected words, and then I correct each word using spell checker. I have taken a loop here which will iterate through each word in the input text, and then I have used spell.correction module here which uses spell checker to correct each word, and then I append corrected words here. Okay, now after I am done with this, I'll start preparing my input for BERT. As you can see, I am start preparing input for the BERT function here. Okay, now when I talk about preparing this input function for BERT, okay, this is the most important step here. Okay, I'll start preparing the input function for the BERT. So first I join the corrected words into a single string. Okay, so we are using the separators here, CLS and SEP. If you remember, when I was explaining you about BERT, I explained you about this, right? So this will prepare the input adding CLS, which means beginning of sequence, and SEP for end of sequence tokens. Okay, now using these input IDs, I'll tokenize the input text using BERT's tokenizer and convert that into PyTorch. Okay, so once I am done with this, I'll go for BERT prediction. As you can see, I'll go with BERT predictions. I am done with using spell checking. Now I'll use my BERT model. Okay, so I'll feed the input IDs into the BERT model. As you can see, I'll feed all the input IDs into the BERT model, and then I'll retrieve the prediction from the model's output. Okay, so the prediction has some shape. I'll retrieve the models from the predicted output. Okay, after that I replace the mask tokens. I'll initialize an empty list here again. Okay, I'll initialize the empty list to store the redefined tokens. For token and predicted tokens, I'll iterate through the process, and if the corrected words are left, I refine them, and then I'll append them to the next list, which handles this particular loop here will handle the case where the more marked tokens are available, in which I can complete the task. Okay, so once I am done with this, I'll go for refining the text. Okay, so I'll correct the spellings, use the model, convert the given tokens into strings, clean up the special tokens, and then finally I'll return the redefined text, the corrected and refined version of the input. Okay, once I'm done with all this, I'll go for testing. Okay, so I've taken a text called this is a sample sentence with some errors such as this NLP model. Okay, so I am defining the test string here with intentional spelling errors here. I'm calling the correct underscore spelling function to correct the given text and print the original text. So as you can see here, the output, this is a sample sentence with some errors such as the NLP model. The sample or given as simple Sentence spelling here was wrong, which is corrected. Error spelling here is wrong, which is corrected. So in this way, we can design or implement spell checker using BERT. Okay, so I have integrated BERT model with another library which is called as spell checker library. Okay, so spell checking is basically used in NLP for fundamental pre-processing tasks that will ensure giving you accuracy and quality of many data applications. So many NLP techniques have been evolved, like I have used spell checkers here in this case, which will continue to improve the process of refining the data through the integration of advanced algorithms and models that will not only enhance their ability to handle complex large language issues but also produce corrections based on the context. So this is all about case study spell checker using BERT model. Okay, so as in last session we have seen other pre-trained advanced models of BERT, you can also try implementing these case studies spell checker using advanced models of BERT, that is you can use Robota, you can use DistilBERT and other pre-trained language models to get more desired and accurate results. Thank you so much.